Howdy, I'm Dr. Hitansh, and currently I'm working on seeing how drug mutates over the years. And right now I'm working on Ebola case, so seeing how that would mutate and how we can come up with a vaccine to help prevent it in the future. However, that takes years upon years, but with HPC it can be done much faster. However, I don't know any technical knowledge about HPC. I don't know how to use it, but with NAI I can do that.
Let's continue with Google. Very secure.
Logging with Google and through Auth0 allows you to save our future queries into the cloud so you can always look at them later. NAI in general is an agentic AI platform that can take in a user query and analysis, whatever it may be, determine the difficulty of it, and based on that, allocate memory and nodes on a HPC service running live, and send a job spec to that service so that the job can be executed in a timely fashion. The main UI we have on NAI is a chat-centric dashboard, as well as a ledger on the side to easily view analyses and graphs as they are generated.
So first, after submitting the query, NAI tries to break down the problem and decide how am I supposed to execute this and how many nodes should I allocate to have the best cost to efficiency ratio. And then once it decides on a general algorithm such as Monte Carlo or parallel computing, it'll have a memory graph which basically tries to approximate how much memory is used at any point during the computation. Now, if you're like Dr. Hitansh and not very familiar with HPCs, you're probably wondering how this all works. So basically, we have an HPC server like this, where we have a bunch of master nodes which can send tasks to their workers. In this example, green nodes are worker nodes that are ready for a task, yellow would be they're working, and red is obviously they're not able to take a task.
Back to like how we actually execute on the user's analysis. Let's say the user says, hey, I want you to analyze my stock portfolio, and they input some medium, say like a CSV file. We will determine how big that CSV file is, how hard their analysis is. We'll take all that context and generate a Python code file that is able to be threaded and parallelized so that it was able to parse through that CSV file like efficiently.
So if you're wondering what the Python code file is, it would look something like this, while the job spec that we send to the HPC would look like this.
And the job spec is pretty important because that tells the task scheduler on a lot of popular HPC platforms like when to put their task in, especially because there's always thousands of tasks running on an HPC cluster at one time.
And if you notice, before our actual job popped up, our task was scheduled and there was a slight delay because in a real HPC, everything doesn't just happen immediately. Servers sometimes take time to deallocate from other previous jobs. So right now it says it's going to take a long time, which it typically does with high performance computing because there's so many simulations that we have to run to actually decide what mutation will this E. coli have in the future. But for the demo, we'll skip the compute and just get our answer in 3, 2, 1. So first up, we have the HPC summary, which is our actual answer to the question. This is general information about the E. coli in a year from now. And since this is about protein folds, we also have a generated 3D model of the fold that we referenced before with the specific atoms and amino acids as well.
The reason why we made NAI is not just for protein folds and not just for Professor Hitansh's case, but so that literally anyone who comes in with a query and if some form of data in any medium that's able to be uploaded can take their query, have code generated that can access and read their query and then actually analyze their query, and then eventually put that into a threadable HPC environment so that they can get their query back fast.
And if you're trying to move this offline, you can also download the .py and the job spec yourself. In the end, NAI's purpose is you can ask anything and learn everything. Thank you.
Let's go.
It's that easy. Ooh.